Hello, our project is construction site congestion analysis and dynamic team composition identification. Construction site is one of the most dangerous site. According to the previous statistics, most of the workplace fatal accidents happen here. IoT helps to collect data in real-time manner to solve construction safety problems. Previous researchers applied RTLS to track the workers and the equipment's location in construction site for safety management like proximity detection, identification of hazard area, occupancy of the site, and alert generation. However, IoT will also help to lead the growth in the data, but big data analytics is a good analytical platform which helps to assist the safety management better. Here the problem is using RTLS. Previous researchers conducted analysis to reveal the accident prediction, but this data is not enough to validate the robustness. Moreover, for previous researchers on proximity events, there were unnecessary alerts generated. As the workers and the equipment cannot work together with same speed, there should be more realistic analysis for the proximities of the workers and the equipment which work together temporarily. We have three main objectives, and they are to find the congested and dangerous areas of the construction site using RTLS data of several days, to find main attributes that correlate to temporary changes of the team composition such as occupancy of hazard, score of grade, activities according to the schedule, type of equipment and velocity of equipment, and to predict the temporary changes of the team composition.
I will explain the proposed method according to each objective. First, we will try to identify the congestion area and the dangerous area of congestion using RTLS data over several days. Here, we have a heat map generated by Chung to show the occupancy of the site. In their study, they separated the site into multiple grids, then they calculate the occupancy score of each grid and generate the occupancy heat map. Similarly, in our project, we will generate grids for the construction site, which size will be 10 meter by 10 meter. Then heat map will be generated according to the occupancy score and hazard score of each grid. In the objective 2, we will try to find the main attribute related to temporary change of the team composition. Firstly, what we are going to do is labeling the dataset by observing the captured video of the site. We can manually identify at what time which equipment is temporarily working with workers, and we will do the labeling to the training dataset and test set. Then we will use the training dataset to build eager learning classification models such as decision tree. And last, by looking into each rule generated by classification model, we will try to understand the level of importance of different attributes and try to identify the key attributes of the prediction. In the objective 3, we will input the test set into the built classification model to predict the temporary changes of team composition. Since we are not sure whether this model fits the data or is the best model for making this prediction, we will also try to apply other classification algorithms such as KNN and naive Bayes. By comparing the accuracies of different prediction models, we will select the best one.
Here, we will show the data sets we have in this project. The data are collected from a construction site of an electric substation in Montreal. Over several days, we have the data sets showing the position and motion of entities on the construction site. In addition, we also have the recorded proximity events that the system detected during the construction activities. At last, we also have the videos of the site, which will be used for labeling datasets and validating the results. The first dataset is collected from an RTLS. Except the position and motion of the workers and equipment, it also shows the type of each entities, time of the recordings, work zones that the entity was in, and the task of each entity. The second dataset is about the proximity events. It shows the related entities in the proximity event, the distance between the workers and equipment, and also the time when the proximity was detected. At last, we would like to show some early findings, and the works have been done already. As shown in these figures, as an example, we have the proximity heat map and the occupancy heat maps on January 28, 2020. The number inside the grid represents the score of the grid. Higher score means higher probability in detecting risks in proximity heat map and higher occupancy in occupancy heat map. The remaining steps of this project will be finishing the REST labeling, generating and applying different classification models. At last, we will compare the different models with respect to the accuracy and error in order to select the best one. This is the end of this presentation. Thank you.